Okay, so today we're going to talk about power. Power is the work done per unit time or the energy transferred per unit time. We represent power by the letter P, and the formula for power is work or energy done per unit time. So this is a very simple formula. So basically, for example, if you have a box and the question tells you that the work done on the box was 150 joules and the work was done in 3 minutes, they might ask you to calculate the power with with which the work was done. So you just simply put it in the formula like power is equals to work, which is 150 joules, over 3 multiplied by 60, because you need to convert the time into seconds, and you'll get your answer. So if you just simplify this a bit, we get 5 over 6. Now 5 over 6 what? The unit for power are watts. So the unit we'll write are watts. Remember this. The unit for work and energy is joules, and unit for power are watts. So the work done on the power with which the work was done on this box is 5 over 6 watts. So the formula for power is very simple, and it can be used with both work and energy, and we'll see in questions how this formula is done is used. Okay, so the next thing we're going to talk about is the efficiency in energy transfers. Now, what this means is that in our real world scenarios, when we're converting energy from one form to another, the energy isn't always converted to the exactly into that form. Some of the energy is lost in the process. So, to give you an example, if we have this battery right here, like this is a battery, and we connected its terminal to maybe a motor. This is a motor. Like this is getting confusing. Let me just, like, this is a motor, and this battery has maybe 10 joules of chemical energy, and we measure how much of the energy is uh, produced by this motor. So we'll see that the energy produced by the motor is less than 10 joules. So it will be less than 10 joules. This is because some of the energy is lost in the form of heat when the electricity is traveling. So all of our circuits are not 100% efficient, and to calculate this efficiency, to calculate how much of the energy that we input was turned into actually useful output, we use the formula for efficiency, which is useful energy output over total energy output multiplied by 100. So the battery provides 500 joules of electrical energy, and the heater which you've connected the battery with releases 300 joules of thermal energy. So we can see that the 200 joules of energy which was originally in the battery is lost to the surroundings or maybe some inefficiencies in the circuit. So not all of the 500 joules is converted into the thermal energy by the heater. And to calculate the efficiency, we just plug these values in. So our useful energy was 300 joules over our total energy, which was input, was 500 joules multiplied by 100. So if we just cancel this out, we'll see that the efficiency for this circuit is 60%, which means that out of all the energy that we input into the circuit, only 60% of it will become useful output. Now let's talk about some other side topics for this chapter. The next one is energy resources. There's two types of energy resources. Let's talk about non-renewable resources first. These are the resources that cannot be replaced once they're used up, which means that if we use them once, they will never come back. They have two very major advantages. The first one is that they have high energy density. Now, what this means is that for a very small piece of this energy source, we can get a lot of energy. An example of non-renewable energy is coal. So, for a small lump of coal, we can release massive amounts of energy. So, they have a very high energy density, and they're readily available to meet energy demands, which means that they're not dependent on any other external factors. We just mine the coal and we have it and we can use it anytime. So the examples of non-renewable energy are fossil fuels such as oil, gas, and coal. These were formed by the living organisms which lived millions of years ago. When they died, their remains were turned into fossil fuels, and burning these fossil fuel can cause air pollution as they release gases such as carbon dioxide and sulfur dioxide, which in turn cause global warming and acid rain. We also have nuclear energy, which is the energy produced through the fission of uranium. We'll read about this more on in the later chapters. It does not release any harmful gases. However, it is very toxic to the environment, as it is very radioactive. So it releases radioactive. It is very radioactive, so it damages the living organisms around the power plant basically. The next energy resource we have are renewable energy resources. These are the energy resources which cannot be exhausted and usually don't cause pollution. So, for example, solar energy, the energy produced from sunlight. We know that we cannot use up sunlight. It is always available for us, and no matter how much we use, we always have more sunlight. And producing energy from solar is doesn't produce any gases, or it's not radioactive, so it doesn't cause any pollution. Now, let's talk about the examples of renewable energy resources. The first one is solar energy. It is the energy transferred by sunlight. By the way, 1 hour of sunlight that lands on Earth is the total energy used by the world in 1 year. So, if we somehow collect all the solar energy which lands on the Earth in 1 hour, we can use that energy to power the Earth for one whole year. That's so amazing. So, solar energy needs large collecting devices due to the low energy density and is dependent on weather, because if it gets cloudy, you cannot get solar energy. You need sunlight for that. Solar energy can be converted into electrical energy using solar panels, or we can use mirrors to focus sunlight into one spot and turn steam turbines. The next one we have are wind energy. Wind energy is caused due to sunlight, which fluctuates the air pressure around us. And we can use giant windmills called wind turbines, which are placed in windy areas and they spin due to the wind. And this in turn rotates the turbines and produces electricity. This energy is much more limited than solar energy because windy areas are much rarer than areas with sunlight, and it is very dependent on location and weather. Next, we have is wave energy. Wave energy is the energy that we harness by the sea waves, which crash on our shore. It cannot be used on a large scale, but small setups can provide island communities with power. Tidal and hydroelectric power are very popular non-renewable energy sources. They are the energy source. These are the energy sources which we harness. Uh, these are the energy sources due to the flow of water from high area to the lower area, and this is used to drive a turbine. In tidal energy, water is held back by a tidal barrier. In a hydroelectric power dam, uh, we use the dams and barrage and setup. Hydroelectric power is fast and reliable. However, it has numerous environmental complications such as destruction of habitats, because to build hydroelectric powers, we need a lot of area, and it can also be very costly. Geothermal power is the power which we produce by pumping cold air into the ground towards the hot rocks and then collecting the steam which is produced by those hot rocks and use it to drive turbines. But this is also done very rarely because it is very hard to find spots which are optimal for geothermal energy. Uh, the next one is biofuels. These are the fuels grown such as